Alright, so this lesson is all about quadratics, and we're going to talk about some special properties that deal with quadratics. So, first thing you need to know, what is a quadratic? It means it's squared. It's going to have an x squared. If it doesn't have a squared, it's not a quadratic, okay? So some things we're going to talk about. We're going to talk about concavity, x and y intercepts, and the axis of symmetry. So, let's just get into it. Concavity, you need to write this down. If A is positive, it is concave up. If A is negative, it is concave down. Pause it, write that down. Now, you're probably saying, what is A? Here's what I'm talking about. So every quadratic, this is what it's going to look like. Y equals ax squared plus bx, that's a b, plus c. So when I'm talking about A, I'm talking about whatever is in front of x squared, okay? If whatever is in front of x squared is positive, then it's going to be concave up. That means it's going to go and make like a little cup. It's going to go up, okay? If A is negative, so like for instance, if I had negative 2x squared, then it's concave down. That means it's going to go down. It's going to turn down, okay? So let's look at the concavity. A right here is positive. That means it's concave up. That means if we graph this, it's going to look like this. Here, example 2, A is negative. That means it's concave down. So if I was going to graph this, it would look like this. Okay? So hopefully you understand the difference between concave up and concave down. Next up. The bigger A is, the skinnier your graph is going to get. And the closer to 0 A is, the wider it's going to get. So look at these two examples. First notice they're both positives, which means they're both concave up. This one is a 3, and this one is a 1/2. Well, 3 is bigger than 1/2. So if you look at the graph, the one with the 3 is skinnier. And that is because 3 is bigger than 1/2. So let's compare the graphs. This one is going to be skinnier. How do I know that? Well, here's how I know. Because here, my A is a 1. If they don't put a number there, it's a 1. Here, it's a 5. Well, 5 is bigger than 1. That means it's skinnier. Here, it's a 1/2. Well, 1/2 is smaller than 1. So that means this one's going to be wider. There's something else that's different about this one. What's different about this one is my original one was positive and this one is negative. So that means this one is also going to be concave down. Alright, how do these graphs differ? Okay, well again, there's two big things I want to point out. The easy one, I think, this is positive, this is negative. That means this one is concave down. Also, this is a 1, this is a 3. Well, 3 is bigger than 1, so that means this one is going to be skinnier because 3 is bigger than 1. So an important thing to note here, we don't really care about the negatives. All we care about are the numbers. 3 is bigger than 1, so therefore I know that the 3 is going to be skinnier. Okay? Okay, so let's go through these real quick. How are these different? Well, 2 is bigger than 1/3, so that means this one's going to be skinnier. You could also put that the second one is wider. It doesn't matter which one you put. Also, what's different is that this one is going to be concave down, and the first one is not. This is a 1, so they're both concave up. That's not different. The only difference is that this one, 2 is bigger than 1, so that means this one is going to be skinnier. And here, this is a 1, this is 1/2. Well, 1/2 is smaller than 1, so that means this one is going to be wider. Alright, next up, C. C is the number at the end, and it's going to shift it up or down. So, this one you can see is at positive 2, right here. This one is at negative 2, down here. Another important thing to note, C at the end is your y-intercept. It's where it's going to cross your y-axis. So this one crossed at positive 2, and this one crossed at negative 2. It's my y-intercept. So again, this just kind of says what I just said. It can either move it up or down on the y-axis. So how do these differ? Well, they both are x squared, so nothing's different there. They're the same width. They're both concave up. The only thing that's different, this y-intercept is at 3, and this one is at 5. So the way I would write that, and I'm just going to type it because it'll be a lot, I would say y equals x squared plus 5 is shifted up 2. Okay, so how did I get up 2? Well, here's how I got it. This one was at 3. To get to 5, that means I would go up 2. Okay, how do these differ? Again, they're both x squared, so that's not changing. All that's happening is y equals x squared minus 5 is shifted down 2. Okay, again, how did I get that it shifted down to? Well, I was at -3. Let me show you a little picture of this. If I'm at -3 here, and I go down to -5, that means I'm going down 2. All right, so what does changing C do? Again, it's going to shift it up or down. What's the best description? Okay, well first, let's see if it opens up or down. Here's how you figure it out. This is a +1. If it's positive, it opens up. So it could be A, it's definitely not B, could be C, and it's not D. Vertex, okay, we haven't talked about that term. The vertex, and I'm going to go back to my very first graph that I had. The vertex is either the very bottom, this is the vertex, or it could be the very top, this is the vertex. So let's look at some more pictures. Here's my vertex here, it's the very bottom. This is my vertex here, the very top. Here's my vertex here, the very bottom. Here's my vertex at the very bottom. Try more graphs. Yep, this is my vertex. This at 2, that's my vertex. Here at -2, that's my vertex. So that's my vertex. That's what that term means. So my vertex, let's look at here. Is it going to be at -5 or is it going to be at +5? Well, look at your graph. It ends in a +5. So that means the graph opens up and your vertex is at 0, 5. All right, so I'm just going to go through these and tell you what's different. So 12, so just listen. I'm not going to write it because it's hard to write on these things. So first up, this is negative. That means it's concave down. Concave down. They're both 1s, so there's no difference in the width. And this one is going to be shifted down 3 because here I was at 0 and I'm shifting to -3, so I'm shifting down 3. Here, this one's going to be wider because this is a 1 and this is 1/3, so I'm going wider, and I'm also shifting up 3. I think you got the hang of it. If you'll go try that worksheet and let me know if you need help.